Hello, everybody, and welcome back to our final lecture in Geography 341, Weather and Society. I'm Dr. Zach Hilgendorf, and in this lecture, we're going to talk briefly about changing weather in a Midwestern world, where we live. So we're going to talk about the Midwest a little bit, but first, just a quick recap. We may recall that in our last video, we talked a lot about anthropogenic global warming. Earth's temperature has risen by an average of 0.08 degrees Celsius per decade since 1880. This warming is a result of anthropogenic activities, adding greenhouse gases like carbon dioxide, methane, and water vapor to the atmosphere, which increase retention of energy, heat, near the surface and kind of lead to these changes in climate and weather. A lot of that's expressed through changes in temperature, like we see in this graph off to the right. This is differences from 1901 to 2000, the average differences. These are basically average anomalies. So 0 is average, and then anything deviating from that is anomalous. So we can see the anomalous stuff was cool or colder or cooler prior to about the 1940s. But since about the mid 1970s onward, we've seen a drastic increase in average global temperatures across our surface. So what does this mean for weather? Well, we may recall weather is driven by differences in heat, pressure, and wind, among a lot of other nuances. But with that, add in some moisture, and a warmer world means more evaporation, more energy, and stronger deviations from the trends that we expect or think of when we think of weather in a given place. So what does that mean for us here in the Midwest? Let's start off with Minnesota. I had to include some silly memes and pictures in here. One in this case looking at snowfall totals estimated for the Twin Cities and surrounding areas. If you're up in Bemidji, it's okay then, sure. If you're in Grand Rapids, that'll do. If you're, well, a little bit north of Brainerd, would you look at that? Quite a snowfall there, I imagine. If you're in the Brainerd band there, could be worse. Alexandria, oh gosh. St. Cloud to the northern Twin Cities, oh geez. Redwood Falls, Mankato, the southern Twin Cities, all the way through to La Crosse, all for Pete's sake. So there's our Midwestern one for Minnesota. I've got one for Wisconsin too. But we're seeing changes across the Midwest. Now, these changes manifest a little bit differently than they do in other places like the desert Southwest or New England or the Pacific Northwest, all these different regions, physiographic regions across our world, or across our country, pardon me. Here we're seeing rapid changes in things like temperature and precipitation. And those are the two things we're going to focus on. So both of the, or all the slides that I've got are from the respective states' Department of Natural Resources websites or other climate-based websites run by the state. So in Minnesota, one of the first things they talk about, Minnesota keeps getting warmer and wetter. Minnesota has warmed by 3 degrees Fahrenheit between 1895 and 2020, while annual precipitation has increased by an average of 3.4 inches. Although Minnesota has gotten warmer and wetter since 1895, the most dramatic changes have come in the past several decades. Compared to the 20th century averages, all but 2 years since 1970 have been warm, wet, or both, and each of the top 10 combined warmest and wettest years on record occurred between 1998 and 2020. Although climate conditions will vary from year to year, these increases are expected to continue throughout the 21st century. Not just that, but it's getting more damaging as well. Heavy rains are now more common in Minnesota and more intense than any other time on record. Long-term observation sites have seen dramatic increases in 1-inch rains, 3-inch rains, and the size of the heaviest rainfall of the year. Since 2000, Minnesota has seen a significant uptick in devastating large area extreme rainstorms as well. Rains that historically would have been in the 98th percentile, the largest 2% of annual events, have become more common. Climate projections indicate these big rains will continue increasing into the future. On the other side of that coin, most of Minnesota's observed warming has been at its coolest over the entire period of record back to January of 1895. Average daily minimum or low temperatures have risen at more than twice the rate of average daily maximum or high temperatures. In the winter season, December through February, has warmed 2 to 3 times faster than the summer season, June through August. Winter warming rates in particular have risen even more sharply in recent decades, and from 1970 to 2021, average daily winter low temps rose more than 15 times faster than average daily summer to high temps. The frequencies of negative 35 degree Fahrenheit readings in northern Minnesota and negative 25 degree Fahrenheit readings in the south have fallen by up to 90%. We don't get as cold as we once did, and even though Minnesota will always see periodic cold spells, long-term decline in cold extremes is all but guaranteed to continue. Here we can see the Minnesota average daily winter daily minimum temperatures. And obviously this is in Fahrenheit. We're working with state agencies. So if we look all the way back into the 1800s, 1896, roughly, starting at our trend line at least, is starting at about negative 2 degrees Fahrenheit. And we are ending at about 4 degrees Fahrenheit. So we've seen an average rate of change of about a half a degree Fahrenheit per decade. And this is just in winter daily minimum temperatures. So our colds are not as cold as they once were. And that's something that, moving on to Wisconsin, we also see. So here's the fun one I found for Wisconsin. Wisconsin's 12 seasons: winter, 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 fool's spring. Maybe we're down towards kind of spring, I think now. More winter, we had that. Kind of spring, mosquito. Stay tuned for that. Summer, fall, Packers, hunting, and back to winter. So I got a kick out of that one. But here, to determine changes in Wisconsin's temperature and precipitation, UW-Madison scientists analyzed records from a statewide network compiled by the National Climate Data Center, or NCDC. Data set shows that Wisconsin has become 2 degrees Fahrenheit warmer and 4.5 inches wetter since the 1950s, with the greatest warming during the winter and the largest precipitation during the summer. Wisconsin's likely to become much warmer over the next few decades, with average temperatures closer to southern Illinois or Missouri. Results show that Wisconsin has warmed 2 to 3 degrees Fahrenheit since 1950, and it's projected that the state will warm by an additional 2 to 8 degrees by 2050. We will also likely see a tripling in the frequency of extreme heat days, those days over 90 degrees Fahrenheit, rising from about 10 days per year in 2020 to an estimated 30 days per year by 2050. Seasonal temperatures have also changed. Spring temperatures have increased by 1.7 degrees Fahrenheit with the onset of spring, defined as the date when daily temperatures have reached 50 degrees for 10 days in a row, coming 3 to 10 days earlier since 1950. Wisconsin winters are becoming less cold and have warmed more than any other season in recent decades, just like we saw in Minnesota, by as much as 4.5 degrees Fahrenheit. It's anticipated that winter temperatures will continue to increase 5 to 11 degrees Fahrenheit by 2050, meaning winters will be milder, about 1 month shorter than they are today, and will produce about 14 fewer inches of snowfall than any time in our history. Wisconsin has become about 10 to 20% wetter since 1950 as well. Again, similar to what we saw in Minnesota. However, the increase is not geographically even across the state. Southern and central Wisconsin have experienced about 20% more precipitation than the annual average, while northern Wisconsin has not experienced significant change in annual precip. Although projections of precipitation are less certain than projections of temperature, scientists report that annual average precipitation will likely increase by 2050, especially during fall, winter, and spring. Further, in winter, we are likely to see more precipitation as rain than as snow, which that sucks. I love winter, especially for the snowfall, and it's sad to think that we will see less and less and less of that as the years continue. In addition to tracking average precipitation, scientists project the frequency and intensity of storms. Extreme precipitation events have had devastating consequences here in Wisconsin, and they've been increasing across the state. The Great Lakes region rainfall in the heaviest 1% of rain events has increased by 31% between 1958 and 2007. These kind of extreme events are likely to become more frequent and more severe as our climate changes. Scientists projections suggest a 30% increase in the frequency of 2-inch rainfall events and a near doubling of 5-inch rainfall events. But that's not the only part of the story. We need to think of this as it's called weather in society, thinking about this from a societal perspective as well. So, weather hazards and societal issues. The U.S. Department of Health and Human Services considers climate change, such as increasing humidity, precipitation, and extreme weather, one of the top public health threats of our time. Extreme heat kills more people in the United States than any other weather-related disaster and can disproportionately affect vulnerable populations such as the elderly, socially isolated people, and those with chronic health conditions such as cardiovascular diseases. Heavy rains and flooding can overwhelm sewers and stormwater systems and increase polluted runoff to lakes and streams. Changes in temperature and precipitation can also impact disease-carrying insects such as ticks and mosquitoes. Wisconsin's reported incidence of Lyme disease, a disease transmitted by ticks, is among the highest in the country. The rate of disease has doubled in the past decade. Many studies have shown that the negative health impacts of climate change are not equally distributed. Structural racism has historically been a large factor in determining what communities are most negatively impacted by environmental health issues, including climate change. For example, people of color and low-income communities are exposed to air pollution and extreme heat at higher rates. Air pollution, when combined with extreme heat caused by climate change, contributes to the disproportionate rates of asthma in people of color and low-income communities. In a study of 108 United States cities, researchers found that when a heat wave impacts a city, poor neighborhoods are hotter by an average of 5 degrees, but some neighborhoods are hotter by nearly 13 degrees. Lower income urban areas typically have more paved surfaces and fewer shade, trees, parks, and green spaces. And residents typically have less access to air conditioning, increasing the risk of heat stroke. A 2020 study of 115 cities by the University of Wisconsin-Madison and the Medical College of Wisconsin found lower tree canopy and higher air pollution in the poorest neighborhoods. And we see here kind of a map talking about that. So heat vulnerability index. Now this is a few different things are baked into this, but kind of inner city Milwaukee has the highest vulnerability based on many of the factors that we just kind of talked about. And as we warm, these problems will only be exacerbated. In other places like I've lived, Phoenix, they are dealing with this in excess at this point. They're trying to find any way that these desert cities can continue to thrive given the stresses and pressures that we're experiencing across our globe. And unfortunately, it is often an equity issue and a privilege to have access to air conditioning, heating, reliable sources of transportation, and a roof over our heads. So from a societal perspective, we need to support one another because weather is only going to get worse or more unpredictable and probably more devastating as well. So with that, I would say that weather is inherently chaotic. What is predictable is that weather will continue to change as our world continues to change. And it's up to us to take those steps to try and improve our world in what ways that we can. And it seems like, one large thing after another large thing, but there's hope, and it is up to us to kind of think about how our actions and what we do as a citizen on this planet and in this country and our state and our community, what we can do to change and improve how our world functions. And then that really has a trickle down to how the planet functions, much more directly, really. So I will say I hope that you have all enjoyed this course. It was a pleasure to read all of your submissions and teach you all and talk with many of you. And I was very impressed by how your weather journals went and how you've continued to grow as meteorologists in your own right. So it was a pleasure. I hope you enjoyed this video, and I will see you in the next one. So have a great day. Thanks.